Hello, algebra students, and welcome to your video today titled Notes, Solving a System of Equations by Substitution. So this is going to be a new way, a new method to solve a system of equations. It says for each example below, solve the system of equations by substitution. So we're doing a different method today than we've done in the past. So let's take a look at example 1. It says solve the system by substitution. And here are my two equations in the system. Now, you do not have to write this next part down. Just watch and observe. What I did here underneath is I went back to the old way we did it. Remember yesterday we solved systems by graphing? So what I did is I took these equations and I wrote them down. There's the y equals x minus 1. That's the first guy. And then I also wrote down 2x minus y equals 4, which is our second guy. So don't write this down, but just know that I'm going to remind you of how we solved by graphing. So if you check out the line that I highlighted in pink, it's already in slope-intercept form. So we're good to go there. We're ready to graph. It's a slope-intercept form. So to graph this line, I would start at my y-intercept here, down 1 on the y-axis. And then my slope is 1, so I will rise 1 and run 1. And I'm just going to do that a bunch of times till I get a pretty decent sized line here so that I can truly tell where my two lines intersect. I'm going to go the opposite direction a few times, just get a nice wide range of points here. So I'm going to draw that line just like you would have, or actually just like you did on your quiz as a matter of fact. So there we go. Okay. Now, the next line, not so friendly. If you think about it, this line here is in standard form. And so what we worked on yesterday was changing or transforming standard form into slope-intercept form. So we're going to start by subtracting 2x from both sides. And when you do that, of course, these drop out. Now, don't lose your negative in front of the y. Bring that along. Negative y equals, and then we like to write our x first, negative 2x and a positive 4. So negative 2x plus 4. And because negative y is like negative 1y, we'll go ahead and divide every term by negative 1, which will leave us with y equals a positive 2x and a minus 4. So I'm going to highlight that line in yellow. That's my graphable line. So I'm going to come down 4 from the origin. So 1, 2, 3, 4. And my slope is a positive 2. So I'm going to rise 2 and run 1. Rise 2, run 1. Rise 2, run 1. Rise 2, run 1. Rise 2, run 1. It's hard to say. Okay, and there is that line. So let me graph a nice straight line here through those points. So you can see that the pink line, which was this guy going with the pink equation, indeed intersects the yellow, which goes with this line. And so we name the solution of this system the ordered pair where they intersect. So my solution, the ordered pair that will make both equations true at the same time, is that point right there. So we're going to look at 1, 2, 3, 1, 2. So x is 3 and y is 2. Okay, that's the old way of doing things. It involves graphing. It involves manipulating the standard form to slope-intercept form. What I want to do today is show you an alternative method to the graphing method. We are going to end up with the same solution. That's why I wanted to do this, because now when we do it the new way, you're going to see the connection in the solution. So here we go. So let me teach you the new method. It involves no graphing. Okay, the first thing you want to do is, if you can, you want to find the equation that is already solved for one variable. like slope-intercept form is ideal, because you know in slope-intercept form, you have y equals. And see, your y is all by itself. That's what you want. You want one of your equations, at least, to be solved for a single variable. Okay, so let me bring this down. So y equals x minus 1. So what I want to say here is that this is alone, which we love. So I'll put a heart there. We love when we have a variable all by its lonesome on the left side. Now, the right side, this is going to seem a little bizarre, but I'm going to call that the stuff. So y equals some stuff, okay? Y equals x minus 1, and x minus 1 is the stuff. Well, what do you do with stuffing? You stuff it in somewhere, right? You take a teddy bear that's stuffed, you stuff the stuffing in. So that's what we're going to do. We're going to put x minus 1, all this stuff, into, where's my highlighter, into the other equation right here. And we're going to place it where the y is. So right here, where this y is, we're going to replace that y with what y is. And y is x minus 1. So check out how this is going to look. I'm going to draw an arrow here to show I'm working with this bottom equation. It'll look like this. 2x minus. Now, you know when you plug something in for a letter, you encase it in parentheses. And I'm going to fill in x minus 1 equals 4. So I rewrote the bottom equation. 2x stayed the same, minus stayed the same, but where the y was, I replaced it with the stuff, because that's what y is, x minus 1. The beauty of this is you now have your bottom equation in terms of x. There's no y anymore, so we can solve this. We're going back now to some old learning. We know how to solve equations. So the first step is I'm going to actually distribute. This right here is like a -1 in front of this parentheses. So I'm going to go ahead and distribute that through. So this is going to give me 2x minus 1x plus 1, because a negative times a negative is a positive, equals 4. Keep solving. I can combine like terms here. 2x minus 1x is just 1x plus 1 equals 4. And to solve this, I would just subtract 1 from both sides, so x would equal 3. Now, look at our graphing. X does equal 3, so that's a good sign. Okay, so how do you find the y value? Well, it's real simple. You go back to the stuff. So if x equals 3, check it out. Go back here to your stuff. Then y equals, okay, x minus 1. Well, x is 3. So 3 minus 1 is 2. Done. X is 3, y is 2. Answer, solution, 3, 2. Exactly like the graphing. Isn't that cool? But we didn't have to graph. We just did an algebraic process that allowed us to solve for x and y. Now, if you want to check it, we've done this before, so I'm not going to show it here, but if you take your top equation, fill in 3 for x and 2 for y, it's going to be true. Take the bottom equation, fill 3 in for x and 2 for y, and it's going to be true. This is the ordered pair that makes both equations true at the same time. Okay, let's look at example 2. All right, example 2. You've got yourself 2 equations that are both in standard form. That's a frown, because we need to find alone, a variable alone. In neither of these equations has the x or y alone. But you've got to make a decision. You've got to look at these and ask yourself, which one of these equations would be easy to manipulate to get a variable alone? You can pause the video here and think about that. Which equation, if you manipulated it, would have an x or a y alone pretty easily? and I hope you put some thought into this, it's the pink equation. Look at the y. You see how y is like one y? It's almost alone. If I just move this 3x and slide it over to the right, I will have y by itself. So here's what I'm going to do. I'm going to work on the bottom. So 3x plus y equals -2. Now, I'm going to minus the 3x from both sides, cancel those out. That gives me y equals -3x minus 2. You see how y is alone? I'm going to heart that. That's what we want, aloneness, because now we can call the right side the stuff. So you go to your other equation, the one you haven't worked with yet, which is your yellow. And where the y is, we're going to put the stuffing in. Y is all this stuff, so all this stuff is going to replace y. So it's going to look like this. 4x plus 3. Here we go. Where the y is, we're going to put in -3x minus 2 equals 4. And the rest is easy. Now you just solve the equation. So let's distribute. Boom, boom. So what do we have? 4x. Okay, 3 times -3 is -9. So minus 9x. 3 times -2 minus 6 equals 4. Put your like terms together. 4x minus 9x is -5x minus 6 equals 4. Solve. Add your 6. Pause this video if I'm going too fast. -5x equals 10. Divide by -5. X equals -2. Done. We got the x. How do we get the y? Take this back to the stuff, fill it in. So here we go. Y equals -3 times, what's x? -2 minus 2. See, I'm filling it in here. So y is, what is that? +6 minus 2. So y is 4. So the solution to this system of equations, -2 for the x, 4 for the y. -2, 4, final answer. What that's telling me is if I were to graph these two, this is where they would intersect, -2, 4. Awesome. Let's go to the back side. 2 to go, and we're done. Okay, solve the system. All right, cool. Check it out. Look at your equations. We'll go yellow and pink, so feel free to grab highlighters if it helps you. Here's the yellow equation. Here is the pink. Okay, well, do we have a variable by itself already? Well, not in the bottom. That's in standard form. X and Y are together on the same side. They're not isolated. But look at the top. We do. X. Look at this. X equals 5y. Look at this. Alone. Heart. We love that. This is the stuff. Perfect. Now go to the other color. Go to the pink. And where the X is, right here, stuff the 5y in, because that's what X is. So it's going to look like this, parentheses, 5y minus 3y equals 6. That's easy. 5y minus 3y is 2y equals 6. Divide by 2. Y equals 3. Done. Now we got the y first. That's interesting. But how do we get the x? Well, you go back to the stuff, like we always do. So x equals 5 times y, which is 3. So x is 15. Done. That was easy. My answer to this problem, put it as an ordered pair. 15, 3, x, y. That's the answer. That's where those two lines intersect. It's the value of x and y that make both of these equations true. And the last one, example 4. Check them out. Let's go yellow and pink. Now, I don't see a variable alone. Not quite. But you got to think to yourself, what's the easiest variable to get alone? Pause the video, think about it, get an answer, and then come back to me and we'll talk about it. Okay, you're back. I hope that you said the top equation will be easiest. Because see, that y is almost alone. All you got to do is minus 6. And now y is alone. Y equals 3x. Take away 6. This is alone. Heart. This is the stuff. Where does the stuff go? In the other equation. The untouched equation, which in this case is pink. And where the y is, we're going to stuff in 3x minus 6, because that's what y is. See, equals means is. Y is all this stuff, so all this stuff can go in for y. So we're going to have 9x minus 2 parentheses 3x minus 6 equals 3. Finish it. Distribute. Ding dong. 9x minus 6x plus 12, catch that, negative times negative, equals 3. Combine your like terms. We got 3x plus 12 equals 3. Minus that 12. 3x equals negative 9. If I'm going too fast, pause me. Divide by 3. X equals negative 3. Done. Take this, go back to the stuff, and get your y. Y equals 3 times negative 3 minus 6. Y equals negative 9 minus 6. So y equals negative 15. As a solution, as an ordered pair, your final answer to this problem, negative 3, negative 15. The end. So great work. Now listen, if I went too fast, if something's messed up, you're confused, I suggest going back and watching this video again. It's the same idea over and over again. It's a little bit of a recipe, okay? So you got to work with me. So you're going to get a mastery sheet now, and I need you to work on that mastery sheet. Make sure this sinks in. So this is your second method to solve a system of equations. Thanks for watching.